Hello, I'm Neeraj. So today I will discuss about the Generative Adversarial Network or GAN architecture. The main purpose of this discussion is like these days still we are using GAN in a lot of different applications. For example, style GAN and a lot of such kind of architectures gives a lot of creativity. Means For example, style GAN and a similar kind of architecture provides us flexibility to achieve a lot of creativity with images and videos and a similar kind of architecture we are using for audio and text data also. Similarly, we can enhance our images also. Another thing is like data augmentations. Instead of depending upon the fixed kind of augmentations, we can use the GAN based augmentations to train our system in a more effective ways. Again, another thing is like when we have a less training data, then in that case we can use the GAN architecture to generate the extra data and improve the training accuracy of the system. Another thing that we can do with GAN architecture is to increase the generalizability of the system. And there are a lot of other things that we can do with GAN. For example, adversarial attack. You already know that what is adversarial attack. So we can use that a lot of these days a lot of architectures use the adversarial attacks to improve the training accuracy of the systems. That's why I think that GAN architecture is highly important these days. So we decided to capture this tutorial. Now, as a layman term, I can explain that GAN architecture is just a combinations of two competitor neural networks. So one neural network we can show like a generator model or a generator neural network. The task of this model is to take the fake or random samples and generate the useful or good images or creative images or true images. Now the another neural network model is like a discriminator model. So the task of discriminator model is to check that whether the image generated by the generator model is real or fake. So by combining this, the system work like a zero-sum game. So here the agenda is to train the generator and discriminator model in such a way that discriminator gets the highest capacity to differentiate between the real and fake images, and generator can also get the highest capacity to generate the real like images, or it can serve the purpose for which we are using the GAN, means a generator model. So this is the target, and for this it uses a loss function. So the vanilla loss function that we use is known as we can say it like a binary cross entropy loss, but it is but you can see that here some terms are totally different. So we will go through one by one like how it is working. So let us go through the cost functions and understand the cost function. Then it will be easy to understand that how the entire GAN network is actually working. So here we see that G, we are using the G to represent the generator model, D to represent the discriminator model, Z to represent the random noise or fixed input vector, means fixed sized input vector which is actually noisy, and X is the real images that is captured from some database or some real source of images, some source of real images. GZ is that is the generated images when we feed the noisy data to the generator model. And again here you can see that P data X is used here. So it means like a probability distributions of real images. And then PZ Z. This is the probability distributions of fake images. So it is used here. And then dgz. So this is a function, means gz. This is a function of d is a function of, sorry, we can say that is a function of function kind of things. So dgz, we can read it like for now. So it is like a discriminator output when we pass this generated images. So what will be the discriminator output? So discriminator output may be either d and when we pass the real, the discriminator output will be dx. So discriminator will give two outputs. So based on that, it will decide whether it is real or fake. Now let us try to understand the terms used in the loss function. So first of all, how we will read this? So we can read this like expectations of log of dx, where x is sampled from the p data x, means probability distributions of real images. And similarly, we can read this part as expectations of log of 1 minus dgz, where z is sampled from the probability distributions of fake images. So now, as a generalized format, the purpose of this loss function is to minimize the loss of generator function and maximize the loss of discriminator functions. But when we use it in the form of binary cross entropy loss, we say that we are trying to minimize this part, like minimize the loss when the data is generated by, like we can say that minimize the loss of log dx. Here you can see that what is dx, the discriminator output when the real image is there. So we are going to minimize this loss, and now we have to minimize the loss of 1 minus dgz, means we are going to maximize this, but here we are going to minimize the overall loss so that we can finally minimize the error of the entire system, so that the discriminator can maximally learn to differentiate between real and fake images, and generator can maximally learn to generate the near to the real images from the fake data. So once we use this loss function, and we use this loss functions, and based on that loss functions, we will apply the back propagations, gradient descent based back propagation, and update the weight. So now once we train this system after back propagations, we use it like we can directly use only generator function or generator model. So how we can use the generator model? We can use the generator model to do a lot of things. If it is a part of style GAN or some other GAN, we can do some generate creative images. We can generate data augmentations, means here we can use, and we can use the combined things, discriminator and generator model, to train the system to learn through the adversarial attacks, or a lot of different uses are possible. So it depends upon you. Now I will go through some more detail. So the next details that we are trying to cover is like how we can construct a GAN from scratch. For that, first of all, we have to understand that how different parts of the GAN architecture is actually theoretically connected, and then we will try to understand that how easily we can write the code for each part.